Well, hello, everyone. I was just listening to the nice music. Welcome to this week's KM World Magazine webcast series event. Thank you all for coming. We've got a big day today, and we've got a lot of people online. My name is Andy Moore. I'm publisher of KM World Magazine. I'll be your host and moderator today. As I kind of mentioned, today's presentation is part of an ongoing series. So please join us for each of these events. They're usually on Tuesdays at this time, but check your website and check your email for the schedule of this series of educational, live, interactive web events. Thank you for coming today. I'm pleased to welcome all of you to this installment, which we are calling Game-Changing Breakthroughs in Knowledge Management with Unstructured Content. Everyone knows intelligent consumerization has led us all to expect more intelligent ways to find things in everyday life, ranging from route maps to what songs to play on Pandora, what movies to watch on Netflix, what to buy on Amazon. We can ask Siri anything from the weather forecast to the latest score of the game. And when exactly was Mom's birthday? Dramatic advancements in heavily proven semantic technology are making it possible to find the most relevant business information, not just personal information, but business information among vast internal and external unstructured content repositories as quickly and easily as we can find things in the consumer world. So as a result, knowledge workers can now make more informed decisions that are supported by the most relevant content and information in less time and with less effort. So that and more is what we're going to be exploring today with our expert speakers. A little bit of housekeeping. There will be an interactive Q&A session after the presentations. Please ask your questions at any time during this event. You've got a text box on your screen right now. Just hit submit. I'll read the questions aloud, but never fear. If yours isn't asked during the event, we will get you an answer offline after the event via email. So let me cut to the chase and get to our speakers. Our first speaker is going to be John Falahi. He's Chief Strategy Officer at Content Analyst Company. He's responsible for the company's product strategy and vision. But prior to this, interestingly, he was a principal product planner at Microsoft, where he was part of a small team, and small for Microsoft, for setting the Office product division's long-term product direction and strategy. And then later, we're going to hear from Roger Bradford. Roger is CEO of Maxim Analytics. Roger is the founder and CEO of Maxim Analytics. Maxim provides technical support to organizations implementing modern data analytics capabilities. Roger has more than 20 years' experience in data analytics with an emphasis on analysis of unstructured data. So he's the right guy to talk to today. There are more details on the two speakers' bios. If you click the bio tab, you can read those, but you can do that any time. So I don't want to take up any more of their time. So I'm going to say, please help me welcome John Falahi.
Thanks, Andy, and thanks everyone who's out there watching this webinar. We appreciate your time and interest. Hopefully we'll cover a lot of information in the next 5 hours. Oh wait, we only got about 50 minutes. So in 50 minutes, we'll try to get through A little bit of an overview, give you a number of use cases. Roger and I will be interacting quite frequently, changing, so you'll hear Roger in a second. Prior to joining Microsoft, the reason I got to Microsoft was Microsoft acquired a company I was at for a long time, Fast Search and Transfer. And Roger and I will both have been through the war, so to speak, and I'll let Roger talk in a second about that, where when I was there, we were building online systems for Dell and Nordstrom's and Best Buy and lots of internal systems for our friends in the intelligence community and inside of pharmaceutical companies and financial players. And those systems were great when we first built them. They were seven-figure systems designed to build and develop these solutions to get the information and manage the information effectively for people. The problem was, with most of the traditional systems that were used at the time, Boolean-based keyword systems for search, that the issue wasn't the initial installation, it was the maintaining or building or keeping up with the dictionaries and synonyms and all of the things that were underneath the covers. So when I left Microsoft, I went to look for a solution that kind of helped that problem. So that's my background. Maybe, Roger, you can spend a second and give a little bit of your background on this same topic area.
Well, most of my career I've been working for system integrators, building information processing systems for government and commercial customers. And years ago, we built systems doing the best we could with the tools we had at the time, but I was always bothered. I always enjoyed working with the users, and users had requirements that we just couldn't meet. And they're not unreasonable requirements at all, and I always felt badly about that. And then about 15 years ago, I had a great opportunity. I was a technical fellow at SAIC at the time, and they let me concentrate on semantic applications, which I've been doing ever since. And now we've been able to develop the tools to really let people do many of the things they've always wanted to do.
Excellent. So we'll, over the next little period of time, as I said before, not 5 hours, about 45 minutes, help you kind of understand and get a little perspective and hopefully some education and some insight that can help you going forward. So what we're going to kind of cover over this period of time is a little background on some of the challenges that we all face with the current systems. What are the good things that people have done with knowledge management and information action systems today, and what are some of the challenges? As Andy pointed out, what's going on the, quote, commercial side or in our personal life that hasn't kind of crossed over as effectively in many areas inside the four walls of the enterprise. We think we have something that will help you and is really a breakthrough in the way people will be able to use this kind of technology that's been around, and we'll talk about some solutions, but actually make it cost-effectively accessible to people and allow them to solve a lot of the problems going on, and we'll actually give a live demo. But then we'll come back with a number of examples to show you that the kind of technology and the problems that solved, hopefully you'll get some insight and some ideas, and we'll go from there. So let's kick this thing off and get busy. So what's going on today? A couple interesting facts from IDC study last year that I thought all of us would feel close to home about. One is that it says knowledge workers spend about 16% of their time searching for information. That's almost 1 day a week. On the flip side, when they're active in that, they only 56% of the time find the information they need. That means, again, about half the time they're not finding what they need. They keep looking or keep going back in. I think even that number is skewed from some of the experiences we have. If we break down the way people look at things or try to find things, there are kind of two categories. One is if they're looking for something specific. And Boolean engines and keywords can do a great job. I know the author's name. I know some keywords in the title or in the body. I know where I saw that document before. I just need to find it again. Or there was someone built a great taxonomy and there's a great tag and I know how to get to that group of documents because they were tagged by me or by somebody else I know, and I can grab them. The flip side is when I'm trying to find something conceptually, I kind of know the parameters about it, I know kind of the key terms or concepts that I'm looking for, but that's harder to describe in a few words, or maybe the tags don't align, or someone that tagged it might have tagged it from their perspective, but not from my perspective, or the terms have changed over time. And that's when these kinds of traditional systems where everything is predefined by someone over time versus the system learning from the content and the user really falls apart and where the frustration comes in. So maybe we can take a look at, what can, knowledge management systems in different kinds of organizations, content management systems, information access systems have been trying to do. They've been busy working on optimizing all those things that we just talked about, the dictionaries, the keywords, vocabulary, controlled vocabularies, improving the metadata, and trying to, at all times, teaching the system what's going on so that you can get relevant results out of each application or solution. And that's also one other variant that people keep forgetting about. What I've used in my Documentum system and the way the words are used, the navigation, the vocabulary that's spent, the taxonomy in that might be radically different than my SharePoint system, than my file server, or anything that I'm looking for out on the web on some of the most popular sites that I use for information. So the whole thing about how do we get the smarts now from us humans telling the system everything up front, the relationships, and the system start to work like a person, starting to understand and identifying relationships so it can effectively find information for us versus us trying to do all that work up front. And as Andy said up front, this is the problem that we face inside the firewalls, but outside, for most of us, we've seen major companies and major investments go on to do things around Pandora for music, for Siri, as he said, where you can actually talk to your computer or your cell phone, and it goes and searches and finds things. But here, these investments in the work going on are large efforts where there's a large amount of revenue dollars generated or hopefully generated by making the investment. So they're using a class of tools that in building complicated solutions to get that system to learn or understand so it can interact a better way than just a few keywords or strokes. But maybe the best way to understand some of the work going on behind the scenes is to take one particular case. And Roger, maybe you can spend a little bit of background here helping us understand how one company, Netflix, took on this challenge to figure out how can I get the system to give us a better way of understanding what users want and get relevant results.
Yes, well, this was just an amazing story. So a few years back, Netflix observed that there's a growing proportion of their revenue is coming from their recommender system. When people went to their website, they had algorithms that based on previous ratings of movies people had done, it would predict what you might like in terms of movies you might want to rent. And because that was becoming a real driver of their revenue, they wanted that portion of their business to be as efficient as possible. So they organized a great competition. And they carried it out in a very scientific fashion. They put a lot of data out on the internet. They put out over 100 million ratings of almost 18,000 movies by almost 500,000 of their users. They set up a test environment so that people could test algorithms for trying to do a better job in their recommendations. And they offered $1 million prize for anybody who could do better than their current algorithm by at least 10%, and whoever had the best algorithm. And when you think about it, this is a very difficult problem. You're dealing with, on the one hand, user preferences, which are notoriously difficult to deal with. And on the other hand, you're dealing with complex objects. I mean, how many attributes are there of a movie that might affect whether you liked it or not? So they faced the whole world with a very difficult problem and offered this $1 million prize. And they had an enormous response to it. There were over 40,000 research groups around the world in industry and academia that responded, came up with algorithms to solve this problem, entered them into this contest. This went on over a period of 3 years. So this was by far and away the most comprehensive scientific evaluation of a data processing problem this side that's ever been carried out. And in fact, one team came up with the winning solution, and Netflix awarded them the $1 million prize. We learned a lot from that competition. I think the key things we learned were, one is you can solve very difficult problems dealing with data. You can solve them at scale. you can solve them in a completely automated fashion, and you can solve them in a way that doesn't require any human handcrafting whatsoever. And those are really important things. The other thing we learned is really important is we know the best technique in the whole world for doing that. Because trust me, any technique you can imagine by which you might process data was tried by one of those 40,000 research groups. And out of all of them, the winning solution was focused on matrix factorization techniques. And there's some other techniques involved for, say, adjusting for how interests change over time. But the key thing that drove the solution mathematically is the same techniques that's being used in Cerebrant for the kind of examples we're going to talk about in a few minutes, where instead of dealing with movies which have associated ratings, we're dealing with documents which have associated words.
Great. So the world went off and spent a ton of money to go improve something, and they built a very great solution for themselves. But one of the things that we will talk about is the technology's been around for a while, and as Roger pointed out, Netflix did a test. There's a lot of different solutions out there. The core technology that they picked is similar to what's in Cerebrant. Inside of Cerebrant is LSI technology, latent semantic indexing. And Cerebrant is a new offering that really is a breakthrough for a lot of users. It is a platform that allows us to combine the smarts that we talked about, basically a machine learning system that can understand content and the user and take that information and process it in a way that gives us a richer experience for the user. But the other thing that's going on is that traditionally those things are custom solutions, and we'll talk about a few examples so that you can relate to them. But here, we've put it up in the Amazon cloud, so it's a SaaS offering, so it's web-based. It's easy to load content and leverage content that's already there, and it's very cost-effective. So now what we've done is we've basically taken things that have been traditionally complex or hard to use and put them in behind the scenes and automated the process so that it's easy for anyone to access that. So instead of spending a lot of time trying to talk through the features of something like that, I think the easiest thing to do is to help people visualize that. So I'm going to take a second here, and you'll have to give me a moment. I'm going to actually get a live demo going. I've got to set up the screen, and hopefully we will get this going for you in a second here. Trying to get to the right page. So let's see if we've got. So hopefully you can see CNN up on the screen now. And here's what most people might do in any given day. They could be reading an article, getting an email. So here's today's CNN, and here's a study on e-cigarettes, safer than the real ones. So I click on that article. I am now reading that article, and I say, boy, that is really something of interest. I'm in a business that this is highly related to. You could pick a different topic or different area, but I'm reading these first couple of paragraphs, and I'm sitting here saying, boy, I wonder what else is out there about this that I should know about. So I can now log into Cerebrant. So if you noticed, I should back up for a second. It is a user email and password control feature. When you log in, you get got to pick the right one. You get a dashboard of different content. Now, the beauty here is the content. We supply general news from acquired media. This version is focused, my workspace is focused on pharmaceutical, so I have information from the FDA guidances. We are a licensee of the National Library of Medicine for Medline, and we also have a copy of Wikipedia. But you also notice I have my own information, and you can add information from any source. So we can work with both internal content and external content. But if I go to general news, I can basically give all that text. So if you notice that now that entire 3 paragraphs is part of my query. I've not put in a word or two, and I asked submit it. So the query is up here at the top. I've now gotten 1,000 documents. You know, you can set this arbitrary. I've set it at 1,000. as results. What we find here is things that are highly relevant to the query conceptually. So when I open up the text of the document, I can start to see certain sections are highlighted. And for example, here's a sentence: participants report the perceptions of relative risks of e-cigarettes, smokeless tobacco, and different types of cigarettes compared to traditional cigarettes. So you can see that a number of pieces here are talking about the same thing. It didn't pick a few words, it picked a number of concepts and quickly aligned it to this information. To help people understand what's going on, we also add a term cloud. Now this term cloud is radically different than any other term cloud that you're probably used to. What's happening here is we've actually taken those 3 paragraphs that I've used as my query and asked the system to look at all of the news in this general news content store that I've created and tell me what are the most relevant terms compared to the query. So if you notice, we're getting both URLs, people's names, key terms. So here, it's not just one verb or one noun or a few things associated. It is the key concepts or terms being used. So we can go understand and maybe find better associations, other ideas that we haven't thought of. That same capability is also true for any given article. I can take this article and say, give me the terms. You notice some of the terms are the same, but there are many different terms because the article has got a different story. So we can use the system to kind of learn about what it's learned so we can understand things. The other nice thing about the system is we can work through other sources. So this document to me might be of interest. Now that I've gone into general news and said, boy, that article in CNN is interesting, but this one's the really one that kind of stands out for me. But I want to kind of understand in academia, are there any interesting reports going on about this topic about e-cigarettes and smokeless? So now I'm going off and looking at Medline. This is 25 million abstracts of all the technical documentation given up through the National Library of Medicine. I find the same things, documents, highlighted text, but also, if you notice, I also have a source link. It's at the bottom of the page as I'm looking at it, or right there quickly, and I can go out to the source. So this is the same that would be also true if you pass the URL up from the documents from your internal systems. You can get back to that internal document and see it in its original form. We also have some other interesting factors where we're collecting all the metadata that's passed along. So here, this is the metadata passed from Medline. In the news, if you look at it, it was the metadata passed from that. If you have your own systems where you've probably invested a great deal of time on your taxonomy or put other metadata on your documents, that can come across. And what we can do is leverage that to help people visualize information and results more effectively. So if you're really trying to learn what's going on, here we're looking at the authors. And it says that of the 1,000 documents, one author shows up 37 times. So if we want to look at who are the most popular authors, we can quickly zoom in and see that there's a couple of authors that are really quite popular on this topic. If I click on any circle, I get that author showing up and filtering. And if you notice, he's now become a filter. And we're down to 37 documents. We can go back and look at the documents. The top document is, again, the most relevant to my query, but with a filter saying we want to look at things from KM coming. Again, we get the same capabilities. We can go here, and if I click KM coming, he goes off. I'm back to my normal list. So we have the ability to use tools, the rich metadata that's sitting in the system, plus the smarts of the system that's learned about it, and give us great ways to mine that information. So I can go also and look at other things, like, for example, I might want to look at where is the information coming from. So we can see that because we're using Cummings as one filter, we're also looking at most of the documents sources are being in the U.S. and in England. We can also start to do some other interesting ways of visualizing the information by looking at a combination of both the authors and the locations. So if we can just hover over England, you can see the top authors are highlighted, and a lot of that big area in the middle is just all the other authors that are out there. So we have a way to kind of combine different locations, or we can click on any dot and say, oh, it's highlighting England and it's highlighting, Cummings, but we can also see exactly what documents there are. So we can go back and forth and start to get other ways of mining and understanding what information is available to us and filter. But it's still based on our original query that conceptually pulled in the right information. Here we've kind of given you a quick show of the interaction, the quick view, as we said, to find similar across any other workspace. So now one of the things, though, we can do is show you that you can have your own workspace. Here I've created a private workspace for myself. All the workspaces in Cerebrant can be shared across a team or across a set of individuals or private. In this case, this is my private workspace. Notice I have an admin capability, but I only have admin capability because I have only had the rights to work on to change one workspace. So what I can do is quickly go here, pick some files. I have a set of zip files. Tell it that I want to upload it. I would hit start upload. I'm not going to run this during the live demo. And it would upload the files. You would see to be built, that zip file would be listed here. I would hit build. Unfortunately, there's nothing there. It would go off and build it and then notify me when that's ready. It only takes, for about 50,000 documents, roughly about an hour or two the first time, and then faster as you keep adding. So you have a way to do things and quickly load things. If you have a large repository like Documentum or FileNet, this whole process can be set up to be automated from a connector that you set up to feed Cerebrant, and then that workspace would be available to you just as quickly as easily as before. So the users have a very nice capability to look across any piece of content, whether it's something supplied in the outside like news or the FDA guidances here. What we've done is crawled and harvested all the public information from the FDA so we can find, again, related documents. And at any point, if you're interested in looking at the whole document, you can go right to the source link, and you'll go right to the FDA site and get the information that's there. So we have a very clean and easy way to navigate, learn, and understand. But again, what we're doing is we're using more than one word or a few words, and using a sentence, paragraph, or is defined similar, using the whole document to go find conceptually the best, most relevant information. So as one friend of mine said, this is a really neat system because I can now find the needles I'm looking for in a stack of needles. Not find a few needles in a haystack, which is easy. I can burn the haystack and look at the needles. But when I'm trying to find specific needles in a stack of needles, I really need a different way of approaching that process. So that gives you a quick overview of what we were talking about. Using a conceptual search capability and smart understanding engine to learn both from the user, what they're looking for, and constantly looking at content independent of the source and learning to treat that as a knowledge base with good understanding so that the user can find the most relevant information as they move from one to the next. So with that, we're going to end the demo and get back to the slides. Just to kind of go one more step before we kind of walk through examples, what you saw again is a system that's got a suite of technology underneath the covers with the semantic indexing really is a key component there. But the key thing is you can work with content from any source, internal, external, public information, social media. And for example, one of my favorites is social media. One of the problems with social media is most good content internally produced or externally produced. People follow grammar. They have good language skills. Spelling's usually pretty good unless I'm writing it. I don't, spell checker and I don't get along all that well some days. But when we're looking at social media, we have misspelled words, mashed up words, words used out of context because they're colloquialism to that team or that work group, or could be a buzz term or abbreviation. And that group might know it, but through repetitive understanding, anybody else would do it, and that's what we want the system to do. So the system doesn't have to have it predefined. The system can learn and understand that relationship, which really makes it unique. So I think, Roger, from there, I think the best thing to do is kind of help people understand a few use cases of how this kind of technology has been deployed, but kind of in costlier systems, but to still solve a problem that traditional systems couldn't solve.
All right. Well, a few minutes ago I spoke about movie recommender. Let me talk about document recommenders. So a typical situation here is you have an organization which has a large number of incoming documents. They have users have information needs, and our task is to find the individual documents in the incoming stream that are relevant to these users' needs, and then organize and prioritize the information for the user. There's some really difficult problems there. There's a big problem with the differing worldviews of the users and the people who authored the documents, that even for such a simple task as coming up with a name to describe a common object, tests have shown that two people will agree on that name only about 20% of the time or less. So there's a big potential problem, vocabulary mismatch between how the users think and how the authors may think. And adaptability is really the key here. Years ago, people tried techniques of sitting a user down with these long, involved forms to fill out about what they want and what they don't want. I never saw any of those work well. Modern systems really need to learn. That's really the beauty of the semantic analysis techniques. We can learn two things. We can learn the user's interests, and we can also learn the characteristics of the data. So the best of these systems I've seen work in a background mode where we're monitoring user activity, and we look at things such as what documents do the users view, even more importantly, which ones do they save or print or cut and paste information from it. They're cutting and pasting. What specifically are they cutting and pasting? And learn their interests and follow them over time, because users' interests change over time. Their job assignments change over time. Their level of understanding of a topic changes over time, so their interests become more complex. Same thing is true with respect to the documents. Since we're dealing with the real data in doing this, we learn about the terminology, we learn how it changes over time. Language changes a lot faster than most people really realize. We also see changes because new data sources become available from time to time in the stream. So the learning capability is really key here. And these are very popular today, but when you think about it, we're talking about matching up user needs with contents of documents. There's a lot of other activities other than recommenders per se where you might use that in either human or completely automated information flows.
Great. We'll talk about one more. So in the legal market, where we have another group of what I call the paranoid lawyers, they're trying not to miss anything. They're trying not to have something get out that they didn't see. And they've been using the underlying LSI technology in a number of products. Content Analyst won an award just recently as the #1 OEM supplier to the legal community. So we supply that core technology to a variety of vendors in that space. And that technology has been used for a number of years by the legal community in the e-discovery area. And specifically, they call it predictive coding, where they can tell the system, here's something that is responsive to the case, and here's something that's non-responsive to the case. So the system can take those subset of documents or start to see those documents and say, okay, here are the documents they're looking for. I will find more like this, or I'll take the ones that they say are non-responsive and say, okay, those I'll put in a separate bucket so they don't look at them. For example, something around Project X might be very important, whereas things around fantasy football might not be important. So what we're trying to look at is how do we help those kind of people that might not be experts in that particular issue have a way to have the system help them find the documents that they need to review from a legal perspective. Here's one particular case where a Fortune 100 company was under government investigation. They had a short time to turn it around. They couldn't get enough people on board to do the work, so they needed to automate the step. They had roughly around 5 terabytes, and also about 5.2 million records. What they were able to do is really run through that whole analysis and turn around that whole analysis using latent semantic indexing techniques to help them organize the information and put it into responsive and non-responsive in 8 days, saving over $1.6 million. But the key is, in this environment, the lawyers and the courts have now accepted this technology as a way to make sure that we've looked at all the right documents and validated the process, because they know as the volume of content is going up, especially emails and other types of digital content, there's no way that every piece of document can be hand-reviewed by lawyers without an extended period of time or expense. So how can we get the system to learn from the lawyers, again, in this case, picking documents they say are irresponsive and find me more so I can focus on those and also not look at documents that aren't really meaningful to the case. So Roger, here's one about resume matching. Maybe you can give us a little background on that.
Yes, this is an interesting project we did a few years ago for a Fortune 500 company. Their situation at the time was they were receiving about 500,000 resumes a year. Any given time they would have 2,000 or 3,000 job openings. What they were doing at the time is pretty much what most companies do now. They would take these resumes, they would enter them into a resume tracking system, and the only real tool they had for working with them was Boolean retrieval. And Boolean retrieval is notoriously inefficient for this type of application, so the hiring managers themselves didn't have time to work with the system. They'd go through intermediaries. The intermediaries typically didn't have the subject matter expertise to match resumes and job descriptions. We came up with a system for them where we provided a window on their public website where a person went to that website, could paste in their resume and push a button that says, "Find me a job." And that we would take the same semantic engine that's used in Cerebrin, and we would form a semantic representation of each resume. We would compare it to the semantic representations we had generated of the job descriptions. If there's a good match, we would automatically take that resume, attach it to an email, and send it to the hiring manager. And the beauty of this is really two things. One is this vocabulary mismatch problem I've mentioned. If you had a job description that says the applicant must have some familiarity with configuration management, maybe you've got a software developer, you've got his resume, and he didn't actually use that phrase configuration management, but maybe he lists half a dozen CM tools and a list of tools he knows. Perfect match, you want to be able to learn that. And in fact, that's what the system did. And the other thing that was really a particular value there is the fact you're doing a holistic comparison of the resume with the job description, not just a couple items you might pick out with keywords for Boolean searches, but comparing the totality of the resume to the totality of the actual job description. The interesting thing here, the HR organization in this company decided, okay, we want to have a 60-day trial. We'll run some of the resumes through this LSI system and some of it through the regular system. At the end of 60 days, we'll compare the two. If the LSI adds enough, we'll bring this up on our website. And after 3 days, they canned the test and said, no, the LSI is so vastly superior to what we're doing with Boolean retrieval. Bring it up right now on our website.
Great. Well, let's take another one that maybe a number of people in the audience, I'll politely say, struggle through daily, which is how to deal with proposals and leveraging what you've already written.
Right. This was, again, worked for a Fortune 500 company, a company that did a lot of government contracting. So in that business, building systems, they get requests for proposals from the government, which can be run to hundreds of pages, very detailed, asking what do you intend to do and how do you intend to do it. And then the company in turn writes sometimes these very lengthy proposals, multiple volumes, hundreds of pages, sometimes tens of people work on these things for months, coming back saying, here's what we're going to do, here's how we'll do it, here's the schedule, and so forth. Well, that's very, very demanding work. And it's really a problem because you want to put your best people on it, you want to win the contracts. On the other hand, those best people should be delivering on existing programs. So this company had been in business a while. They had thousands of proposals they had written before. What we did was take the winning proposals that they had written before, use the semantic analysis capabilities to automatically decompose those into topics, index all that. And then we have a system where we could take an item from the RFP, perhaps it said, here's a problem you might encounter, here's a scenario, tell us how you would handle the situation. You could take that chunk of text and make it a query. And that's really one of the beauties of these semantic systems compared to a Boolean system. You can take a whole block of text, you can take a paragraph or a page or a whole document and make it a query. So we take that block of text, make it a query, and then look for the words that had been written previously that were conceptually closest to that particular item. And that saved a lot of time. In a few cases, you would get golden words that have been written by your predecessors that all you really had to do was change the name of the agency. Usually it wasn't that easy, but typically you at least had a template there to go on. And if you spend a lot of time writing proposals, if you actually start with a well-thought-out template, you're much more efficient at writing what you want to write. In addition, there's very important individual items of information where people in the previous proposal perhaps went and derived information from the various labs in the company, how they might apply to a problem, or went back through past performance on previous projects and showed how that applied. So it made it much more efficient. The head of the proposal center indicated he felt it would save him at least $10 million a year. And this is a topic near and dear to my heart, because I've spent maybe a couple thousand hours in my life writing proposals like that. And this, I think, even though proposal is perhaps a special case for some organizations, this is indicative of a bigger problem I see in most organizations I go into, that they really have a hard time getting back to their own information. You go in, you ask them a question, and somebody will sit there and say, you know, old Harry, he's been here a long time. He might remember what we did on that. And you really don't need to do that now. You really can organize information in a way that people can get to it.
Yeah. But, you know, kind of linking what the previous story and this one a little bit, Roger, someone could actually use that same kind of methodology and say, who's in the company, if I had all the internal resumes or job descriptions, who might be good also to pull in on the proposal. So you can treat those resumes just like you're treating the other knowledge base. Who's out there that we could go leverage?
Yes, and manage your own internal expertise is very relevant.
So I've got one more example here that we can talk about, and that's some work that Cerebrant's designed to do with pharmaceutical companies. And that's really helping them where their world is probably, in some cases, similar than any other market. But here, let's talk about one real kind of problem with the regulatory intelligence is overwhelming, and how do you keep up with it? But a lot of times, one area is just, how do I know that there's something out there, that there's an important guidance change or something that's going on that I need to be aware of, because I'm focused on, say, a particular drug and adverse effects for that drug. So I've got to constantly look what's going on in the news. Is there something mentioning, either by users in social media, or is there something that came out from a regulatory agency where they have basically said there's an issue about some type of reaction or some type of chemical that I might be using in my drug, or a competitor's version that's like that. So users need to keep up on it, and there's people that's their life every day, finding and searching both internally, external paid sources, social media, and trying to see, is there something that I need to know about? And even if they use keywords, they might miss something because the way it's worded isn't exactly the same as what they're looking for. They might be typing in their generic name of their drug or the generic problem, but the user or the author might not mention it, but they might mention the person took something very similar and talked about an adverse effect that they want to go follow up on or something. And some of the things that Cerebrant is also doing is starting to save those searches and running them automatically in the future for them. And that's the way that the information can find you, so that we've now turned around that the constant flow is happening. It's learning and constantly updating you. So another example of how people can use the systems going forward. But I think what we can do now is get close to making a quick summary. We've talked through Cerebrant. We talked through 5 examples. Maybe, Roger, you could spend a few minutes here just kind of going back over the benefits of LSI that's been the theme underneath here on why people should look at this as a way of changing the way they do things and getting a breakthrough on the way knowledge management and information access systems can be enhanced.
Well, in terms of benefits, there's a couple things we've talked about. We've talked a lot about the learning aspects of this technology and the adaptability of it, which is really critical. Learn about user needs and how they change. Learn about the content, how it changes. And also the ability to overcome the limitations of keywords, which are quite dramatic limitations in many applications. But a couple other things are important we haven't talked about much. One of them, scalability. There's a lot of modern data analytic techniques that look really great when you have 1,000 objects. They're kind of okay when you have 10,000. They're starting to die if you have 100,000. And so there's real scalability issues. We've used the same semantic engine in Cerebrant for collections of hundreds of millions of documents with no problems. So the scalability is really a critical issue. And I think also the fact it's proven technology. If you're going to adapt this kind of technology for some key part of your business, it's got to be reliable. And in the examples we've talked about and others we don't have time to cover, again, this key semantic engine has been working in mission-critical applications 24/7 in key applications for years now. And I think that's really important. I think the thing that really excites me about Cerebrant is the fact that, as you noted earlier, in the past we built one-off specialty systems over long periods of time at great expense to do these things. Now people can come in and put it immediately to work for their problems without having to buy a data center and buy servers and load software, go right to work solving the problems.
Great. So I guess I don't really have to say much on this last summary slide because you helped me out.
Sorry about that.
No, it's great, reinforcing the point. To me, the future is here, that the real point that I think, to follow up on what Roger said is that the type of technology that has been used and proven in lots of applications that were problems that couldn't be solved any other way or needed to be solved in a way that basically cut time or cost where those factors were fixed. For example, you talked about proposals. There can be projects going inside of companies and you can go look for a while, you can take a few extra days. But on a proposal, you got a deadline. If you can't make it, you don't make the bid. And a lot of the salespeople and field people really feel that pain. In the legal community, they know that they have a time and to get to court, and they have to get the documents reviewed, and they have to share them with the other side what they found. They have limits too, and that's one of the key areas where I think also people kind of don't get a feel for how much they have to deal with information that comes from the outside that they didn't create, that they have to curate. Whether it's a lawyer, whether it's the intelligence community, whether it's your own business, you're taking a lot of content and you've got to figure out how do I use that effectively in my business. And so sometimes you don't have time to curate it or organize it or leverage it as effectively, but it's critical to your day-to-day flow. So how do we get the system to learn from it? Two, make it easy, as you said, to access it. By now having, systems like the Amazon Web Service with this environment set up, an easy browser login, you load your secure content, you leverage other content, use it when you need it. I have a browser on my Windows cell phone. I can access that same software, Cerebrant, as you saw, from that if I need to, or use it on my laptop or tablet. So I think with that, we basically have gone through the key points that we wanted to cover today. But now it's time to open it up for questions. So with that, I'll turn it over back to you, Andy, so we can see what the audience has to ask.
Thank you very much. I'm trying to muddle through this. It was a great conversation. Thank you to Roger and John. Before we get into Q&A, I want to note that there's a survey on your screen. Audience members, of which there are many today. Please take a minute to, fill it out, think about it for a second while we go through the Q&A session. But look at that survey. Thank you very much. I'm going to start by asking, you guys were just talking about the cloud, just in the final moments, really. And one of the questions that has to be asked is, how do you ensure security of content in the cloud? And how do you ensure rights permission to sensitive content of people who are putting things up, taking things down, putting them on their BYOBs? How do you manage that?
That's a great question. We can only manage part of that, right? Because the Cerebrant is a SaaS offering. So what we do is we work with the customers. So the way it's set up is you can you license a number of people for months at a time or years at a time. That's up to you. You can load your own content. Now the content upload and process is secure through Amazon. We can actually work with you and Amazon to make it even a more secure environment if that's really what you need. But once it's in there, we use pretty strong controls to deal with the administration of who has rights to what content. But the beauty, one of the key things about the environment, I get asked this question quite a bit, and the issue is for certain content, if it's so critical to your business, and you have it on a network, then you've basically said it's not as, you're going to have tight security. And who do you want to have liable? Do you want to have your IT staff liable, or do you want to have a major supplier like Amazon, IBM, or pick your favorite major cloud supplier, right? They're going to keep up the security and stuff. If it's that critical to you, hopefully you don't have it on a network that can be tapped in from the outside. But once it's in our environment, the other kind of thing that's going on is the underlying system, LSI technology, which is inside of Cerebrant, is we've converted things into a mathematical model. We keep the information around for some of the text, but that's about it. And to clean it up or to delete it, we do a very secure job. We worked with a lot of companies that security is critical, and we think we've built a good solution. So the cloud is people are getting more and more comfortable with keeping their information there, and it's a very secure environment if you pick the right cloud supplier. Cerebrant is on the Amazon environment.
Only. It's not on-prem in any way?
So the application that we showed you, the SaaS product, is only a cloud offering. The underlying technology you can license from Content Analyst and build your own on-prem solution. That's how we've licensed it in the case where Roger and some of the partners and companies he's worked with, and we have lots of software partners that take that core piece. But the kind of the breakthrough, we're trying to make it easy, clean, and quick for people to use the technology and get it up and running quickly with no overhead or cost other than a simple SaaS licensing fee.
Okay, well that covers John's question from the audience. I have one of my own too. Is this? I guess I don't understand quite whether or not users put content into this repository, or it just is drawn from, daily activities. Do they add their own content?
Yes. So we supply in the base system the news feed for you, Wikipedia. There's a version that includes, for the pharmaceutical market, that includes the FDA guidances, all the licensed information from the National Library of Medicine, Medline, and the open access documents. From there, every other kind of workspace, or think of it as a collection of information that you want to kind of keep separate, whether it's separate because of who you want to have access to it, or the way you want to back it up and store it, or the way you want to organize it, or it could be, for example, one collection of information could be from engineering, another collection could be from marketing, or from marketing, it could be all of our internal documents and proposals, and another set could be just all of our social media information that we're collecting from Facebook and Twitter that we want to look at and across. that information is uploaded and we create one of those workspaces, and then we've done all of the work to make sure that we've processed it so that the engine can do all that understanding of it, and you can use a sentence, a document, or other documents or other ideas to quickly find the relevant information. So yes, the user uploads the content. Because the engine, think of it oversimplified, just like any search engine, the engine's got to index, it's got to ingest that content, understand it, in our case, build those latent relationships so it understands how documents and terms are related to one another, so it can do those conceptual searches for you.
And is that semantic, or do you have to have term libraries to accomplish that?
So one of the key benefits of this is there is nothing preloaded. It learns from the content itself. So we have customers that are using it in the pharmaceutical industry. We have financial services. We have other people, all different disciplines. I hate to say it, and I think Roger will kick me underneath the table, but I think of the core technology as an idiot savant. Until you kind of teach it what, the topic and the information, it's brilliant, but it doesn't know what to do. So it's just waiting there for you to educate it. It's like a person. So once you've loaded it up with a content set and it really understands that set of information, it can do some amazing things. Roger, do you have a different view of...
No, really. I've spent a lot of my time training users, working with users, in using semantic analysis systems, which is a new thing for them because mostly what everybody sees is Boolean systems. And the one thing I'm always impressed with, that working with the semantic analysis systems is a lot more like dealing with another human being than dealing with a computer. And people really take to that well, as I'm mentioning on some of the recommender systems, where all of the really hard work is done completely in the background. The users don't necessarily have to do anything at all. And in one case I mentioned, don't even choose to do anything, even when we give them easy tools to do it, because it's so easy working in that type of environment.
I'm going to ask a question from the audience. And Ralph asked this, and I'm just going to read it because I really don't understand it. But here's his question. Do your LSI models use weighted associations and spreading activation to determine relevance? And if so, what user interface mechanisms do you have for refining both user and target relevance weights? I have no idea what that means.
Okay. No, it doesn't use spreading activation. Really, that's more a concept from neural network approach to life, which is an alternative approach for doing some of these same things. What it uses in LSI is essentially an eigenvalue solution approach, which as I noted, there's mathematical proof it's an optimal solution for some of the types of problems we're addressing, and it's also that very practical proof from the Netflix competition. So no, we don't use spreading activation. There is internal weighting which takes place, but again, that's all done on a learning basis. It's learning from distributions of terms in documents and learning from actions of users, and so it will implicitly apply weights, but doesn't require any active intervention on the part of the users.
Okay, are there language conflicts here? Can you do, other languages?
And I'm glad you asked that. That's really a great strength of LSI, that the fundamental representation is Unicode. All the things we're talking about you can do for any language you can represent in Unicode, which is essentially any language you're going to be concerned with for any commercial or government application. And in fact, not only can you work in other languages and work in them just as facile a manner as with English, there's even a way to use LSI in cross-lingual applications. That's something I spent much of the last 3 years working on, where a person who only knows English can carry out searching and clustering, categorization, and other information processing tasks for documents in other languages that person doesn't know. And recently we've had some very significant advances in that area, where we've been able, in one project I'm working on, able to show that we can come within a few percent of the performance of a person who's a native speaker of the foreign language doing the work directly in foreign language with English language speakers using LSI in this cross-lingual manner. So that's a great strength.
And Andy, that last part that Roger talked about, that is not in Cerebrin. That's a strength of the underlying technology. Cerebrin itself can work in 250 languages. It has a slight limitation because we're doing some other, we're not using just the LSI engine, we're using other text analytics capabilities. So we do have, we're down to 250 languages, but I think that's most
probably
of them.
Close enough.
I think we're pretty close, but I don't want people to think that demo that they saw will work in any language that's out there with any kind of data set. Something we can work with. The core technology is in some other partners' platforms, and as Roger mentioned that he uses, can do some other amazing things. That's just not in the product today.
Well, that's very cool. And guys, thank you very much. We're past the top of the hour, and I need to close us off. Although this has been a great conversation. Thank you very much for spending your time today. But John Falahi and Roger Bradford, thank you for coming today. And, of course, Content Analyst for helping sponsor today's great presentation. I want to tell the audience, if you want to review this event or send it to a colleague to view it, we will be archived for 90 or so days. Use the same URL that you used today. You can view it or share it. And, of course, you can always navigate to any of our archived events at www.kmworld.com. And I want to tell the audience that just for signing on today, you'll be in a drawing to win a Google Chromecast. And I'm going to have to Google that because I don't know what a Chromecast is, but I'm going to look it up as soon as we get off. So thank you and goodbye from steamy, wet Maine. This is Andy Moore in KM World, and I'll talk to you later. Bye.